electrical safety. At the end of this session, I want you all to be able to identify line, neutral and earth wires from their colour codes. Line is the new phraseology that we use instead of live. State some of the possible dangers posed to us by electricity in the construction industry and explain some ways we can protect ourselves from these electrical hazards. Describe what you should do if you can encounter someone who's received an electric shock, and identify different circuit protection devices and give a basic description as to what their purpose is, what they do. Electric shock. If you come across someone on site who appears to have received an electric shock, the first thing to do is switch the appliance off at its source. Okay, might be a consumer unit or a generator. If you can't see this immediately, use something non-conductive like a wooden stick broom handle, for example, to move the appliance away from the casualty. Basically make sure that you don't put yourself then in danger. Okay. If you can, stand on something non-conductive like a plastic toolbox or a stack of papers. And then once it's safe to approach, check for breathing and start CPR, cardiopulmonary resuscitation, if necessary. Okay. Safety first always. Electricity is dangerous. Make sure that you're trained and competent before you work with any electrical equipment. And if you spot any problems, tell your supervisor. If you're working on site, if you spot problems, tell your supervisor the first thing you should do, and then make sure that you stay safe. Electricity can only flow if there is a circuit. It means that it travels from one place to another, but it can only flow if that circuit is complete. And electricity flows through conductors. We work with lots of conductive materials as plumbers. Copper pipes, copper wires, steel pipes, stainless steel pipes we work with. These are all very good conductors. And the human body is also a conductor, so we need to be especially careful when we work with our metal pipes, because there's a risk that they might be live. It actually only takes 50 milliamps to kill someone. I mean, that's like 50 thousandths of an amp, which is not a large amount of electricity at all. What we have showing here is what we call 3-core flex. This is a sort of general purpose sort of cable that would be used normally going sort of to an appliance from, say for example, a plug possibly, or from a fuse switch spur. Okay, in modern wire, our blue wire is the neutral wire, the brown wire is the line wire, used to be called the live wire, and the earth wire, it's a safety wire, is in green. We should be sheathed in green and yellow sheathing. Okay, line is brown, neutral is blue, and earth is green and yellow. We protect ourselves with the earth wire. The earth wire, and alongside that, circuit protection devices, which I'll often refer to as CPDs, circuit protection devices. The earth wire ensures that if there's an electrical leak onto a conductive material, that electricity will go away through the earth wire. Electricity will always take the path of least resistance. If it can go through an earth wire which has got a very, very low resistance, it will quite happily sort of go through that wire rather than through a person who might have a little bit of quite a considerably higher resistance. It's worth knowing that plugs are set up so the earth wire would be the last one to be pulled out. You can see on here you've got your neutral prong here, your live prong here, and then this earth prong, you can see is connected to up here, is slightly longer than both of them, so whenever you pull a plug out, the earth prong is the last one to come clear. Okay, temporary bonding. So here we have an example of temporary bonding, and we should use these things here. We should use temporary bonding whenever we cut into pipework. The reason for this is because the pipework might be live, and as long as there's a circuit, essentially the pipe is whole, the electricity will flow through the pipe and out through the earth wires, the main earth terminal, which we'll look at in the next module. But if we cut that pipe, if we cut that metallic pipe, we're then potentially breaking the circuit. And if we picked up one side of the pipe and picked up the other side of the pipe, we would then complete the circuit. The electricity may flow through us, and we could then potentially die. So what we should always do whenever we cut into a piece of pipework to an existing property is we should put a temporary continuity bond each side before we cut. Worth noting, temporary continuity bond is made up of multi-core cable, lots of thin strands inside the cable, and it should be at least 10 millimeters in diameter. Now we're going to look at some circuit protection devices. Okay, some CPDs, circuit protection devices, is an RCD, which stands for residual current device. This is a very useful bit of kit. This actually senses if there's any electricity that's kind of leaked out of the circuit, and it will immediately shut the circuit down within milliseconds to make sure that people remain safe. And miniature circuit breakers. Miniature circuit breakers are essentially a newer version of fuses. Okay, you see here the cartridge fuse just here. But MCBs, miniature circuit breakers, are the newer version of that. If too much current is flowing through into the circuit, then the MCB will switch it off, just like the old style fuse. If too much electricity is flowing into the circuit with a fuse, it would cut it off. Whereas the RCD, residual current device, will measure if there's any electricity leaving the circuit. And both of them together would be required to ensure the maximum amount of safety. Fuses are essentially a weak link in the circuit. There's different sized wire inside, and if too much electricity flows through, they literally just heat up, and then they burn out, they pop, they break. And you can see here the different sizes. MCBs, circuit breakers, essentially, like I've said, do the same job as a fuse. It shuts down the supply if too much of a current flows. The handy thing about an MCB is the fact you can flick it back on again once you've found the fault. You don't need to replace it. It switches on and off. An RCD measures the amount of current flowing in and flowing out. Very clever bit of kit. Essentially, it's got like a magnet, electromagnet, sort of in between the two poles of the electricity flowing in and the electricity flowing out. And if there's a difference in what's flowing in and what's flowing out, the magnet, it changes the magnetic field and it automatically switches it off. Really sort of brilliant bit of kit. Very clever person who designed it. So before you work on any electrical system, you have to make sure that it's been safely isolated. And you do that by switching off the circuit that you want to work on. You should also make sure that you lock it off and check that the circuit is dead before you do anything. We'll talk about that in a lot more detail in the next PowerPoint. Okay. Quite often the best place to isolate is at the consumer unit. Okay, now it's time for your task.